3. So, but today is more scale factors. Yesterday was more scales. So scale factors is what we do today. Scale factors K, that's the letter we use for it, is similar to a scale, but it is written in sorry, I'm trying to rephrase this, as a fraction, decimal, or percentage. It has no units. Comma. So we may need to convert in order to cancel them. So when you have feet and inches, you want to convert both to inches so you can cancel the units. You don't want them anymore, right? So scale factors like that. So in general, K is equal to diagram over actual, or the scale factor can be determined by just simply taking the measurement of the new and divide it by the measurement of the original. And it goes without saying that if you're talking length, then it's length of the diagram and length of the actual, width of the diagram, width of the actual. You can't mix and match, okay? It's got to be corresponding, okay? So I will box this in. Okay. Convert a scale to scale factor. So I'm going to go like that, make it nice and fancy. Look at that. All right, 1 centimeter. So let's say you have a scale where 1 centimeter represents 23 meters. Right, and the actual. So this would be considered a scale. Okay. To get that into a scale factor, we would just you use that letter K, and you take the first number like that, and you put the second number below like that. This is scale factor. So you can easily go from scale to scale factor. It's not a problem. We want to cancel the units, so we try to just convert that to centimeters, which is just multiplying it by 100. I'm just fine with you doing that automatically. You don't have to show me the steps when you're converting within metric. Okay, so then you cancel out those units now. That's what you want. Okay. So here, K is equal to 1 over 2300, but it can also be written as a decimal. Use the same calculator. Oh, Who didn't have a cable? Was it you? Did you catch? Oh, perfect. So we're going to go 1 divided by 2300, right? And you get, oh. So what is that? See, what would this do if we did that? So it just means that the decimal shifts over 4 places, right? That's all it's doing. So you write down 4, oh, leave some room for the zeros, right? 4, 3, 4, or something like that. And we go 1, 2, 3, 4 places right here. And you just fill in with zeros in between like that. And this should actually be a 5, right? Because 4, 3, 4, 7, that's 7 bumps this to a 5. Then you've rounded correctly. So we can state it as a fraction, as a decimal, and times 100, right, to multiply to get it as a percent. So to go from here to here, I just multiply it by 100. So these are the 3 formats you can state your answer in. We will sometimes, I will ask you for a specific one on a test or quiz, but you should be able to do either one or one of the 3. Okay. So we went from scale to scale factor and did a whole bunch of things here. Go ahead. Okay, so just a couple notes. If K is greater than 1, greater than 1 or 100%, that means that the original has been enlarged. So if K is equal to 1, no change, exact replica. If K is less than 1, or less than 100%, the original has been reduced. You should be able to tell me that just by looking at the value of K as a decimal, as a percent, as a fraction. It doesn't matter. You should be able to see that. And maybe over here on the side, K is greater than 1, K is equal to 1, K is less than 1, if you like, just to summarize it. So always asking yourself what happened to the original or the actual, right? Some more examples. K is 2/3. If K is 2/3, Sometimes it's best to state it as a decimal. So I'll show you what to watch out for. 2/3, right? It's 0.6 repeated. You can write down 0.67 rounded to 2 decimals. But if you want to state that as a percent, you got to go back to the original and multiply that by 100. So you get 66.67%, right? So don't use the decimal to get to the percent, go back to the fraction, right? Divide, multiply by 100. And so all of these indicate, right, that it's a reduction of the original. K is less than 1, therefore reduction of original. Or the actual, we can throw that in there so that you get used to seeing both of them. You could have K is equal to 380%, right? That translates to 3.8. And watch this. This is a cool trick with your calculator. If you want to state any decimal as a fraction, grab your calculator, type in the decimal, so 3.8, and then you go math. There's a math button underneath alpha. Like if there's a green alpha button, you want to press math. And then just hit enter, because you can use your arrows to select which one. You're going to select fraction. And it's a reduced fraction. Yeah, you don't need to reduce fractions anymore. This is now your friend, right? So 19/5. How did we get from here to here? Math, right? And then enter. That's basically what we did. Not always. Some decimals, it cannot do it. Like if it's a infinite decimal, whatever, it always keeps repeating in various patterns. It cannot do it, but most of the time you'll be fine. So anyways, K in this case is obviously, just by looking at that, is greater than 1. Therefore, largement of original / actual, right? So we always look like what happened to the original to get the new or the diagram, right? Okay, concepts. How about we do this? We just add that you could also state that it's less than 100%. And here K is greater than 100%. We did not need to turn it into 3 formats, but I wanted to do that so you know how it's done if you were asked to do so. Okay. Okay. I think I'm gonna do a few more examples here. Mm-hmm. Give you an example here. Example given that the following shapes are similar. And we talked about what similar means yesterday. When two things are similar, they've been affected by a constant factor. Okay, given a determine we're going to find the scale used. We're going to find the scale factor. We're going to determine the unknown dimensions. So try to copy this diagram. I tried to pick one that's doable. So maybe just watch me first. So these are my two similar shapes. And we have 2.8 inches here. And we have 10.08 inches there. This is my one of the unknowns. This is 4.3 inches. This is 30.24 inches. And this is Y. And why not? Let's write original in here. So we know that's what we started with, right? Because you need to know which one did you start with. If you started with this as your original, then obviously there's a reduction that happened. But we're starting with this one, so it's an enlargement, right? I hope the numbers all, this is at 10.08 here, the little slant. So the scale, don't mix it up with scale factor, okay? That's a common mistake. The scale is the ratio, and the scale factor is usually a fraction or a decimal, right? So don't mix those up, and you cannot have units in it. Scale is okay to have units. So we're going to go scale. We're going to make a note that we know that it's new and original. Study sheet would tell you that if you need a reminder. And you're looking for two sides that correspond that you know both dimensions for. And in this case, it would be the slant, right? Both slanted sides, they correspond and you know them both. So that's the one you're going to use to come up with your scale. So let's go ahead and say that the new is 10.08 inches. We're going to write down the units. And this is 2.8. And then, because the units are the same, we can actually cancel them out. If they had been different, you leave them. In this case, they're the same. We can cancel them out. So write down 10.08 to 2.8. Now, does that look like a nice scale that you could work with? Right, I would say probably not. So here's where I introduce the calculator again to help me out. Grab your calculator and go 10.08 divided by 2.8. Like just divide them. You get a decimal, right? You follow, everybody, right? Now you're going to go math again and hit enter. So it's saying, hey, the answer 3.6, you want to turn that into a fraction? I say yes. And that is 18.5, right? So I can just say where the 18 is going to correspond to that one, and the 5 is going to correspond to the 2.8, right? The bigger number goes with 10.8. So you just turn that into a fraction, but you still know that you're talking scales, okay? So this is it. I will show you how this is done. 10.08 divided by 2.8, and then the answer, you turn that into a fraction, and you get 18/5. That way, if you're looking back, it's like, how did I do that again? Right? That's what happened. Right? And actually, you did quite a bit of work for B already. The scale factor is just going to be this, because remember, it's new over original. So the scale factor is going to be 18/5. Units are already gone, and it's already reduced, right? No units. Check, right? I will also put down reduced. Because it's so easy to reduce a fraction, I will ask you to do that, okay? So, I will just see math. Yeah, so for example, I'm going to clear, let's say you have a fraction 15/18, right? So you go 15 divided by 18, and you want to reduce it, you go math, fraction like that, and it will reduce it for you, right? So either you do enter, you get a decimal and then get it to a fraction, or you do it right away, it's up to you. But reducing should be a breeze, right, with this. So, and if you get the same, that means it can't be reduced, right? Like some students are like, what, I'm doing something wrong. It's like, no, it just can't be reduced, okay? So that's that. We got our scale. We got our scale factor. It could be stated as a decimal percent. It's all good. And C, let's find the unknown dimensions. We can use the scale factor. So to solve for x, I'm going to use the scale factor, which is 18. Remember, that is the constant by which things have been enlarged, okay? So 18/5, no units. And let me go to the diagram once. So this is the original, this is the new, okay? So the original is going to go down here. That's just because this reminds us of that, right? So the original is going to go here, x, and the new, those are the two sides that correspond, that kind of belong to each other, right? And so that's your setup there. Solving for y, you do it the same way. 18/5 is equal to, you just have to place it in the right spot, right? So I'm going to go back to my diagram. And these two correspond, right? I'm going to put the new this time up here, and the original goes in the denominator here. So I did that on purpose so that you have both scenarios, but I always start with k, and then I will go grab the numbers and place them in the right spot. And of course, the variable goes on the other. So then you cross multiply. So you have 18x here. And you have 5 times 30.24 on the other side. Divide both sides by 18. X is going to be 8.4. And we are in inches, so that's what you're after there. And over here, you cross multiply like that. This times that, right? So 4.3 times 18 is equal to 5 times y. So because 5 is going over multiplying here, I put that on the right side, divide both sides by 5. So it's 4.3 times 18 divided by 5, and that's 15.48 inches. There you have that. Okay, good. Are we good with this? You able to follow? Don't fall asleep on me. Okay. All right. Let's keep going. More examples. We're going to do some word problems here. The diameter of a cell is 0.25 millimeters. In a textbook, the same cell is depicted with a diameter of 3.5 centimeters. A. Determine the scale used. B. State the scale factor. Three formats. C. Is this enlargement or reduction? By how much? Okay. Take a couple minutes and see if you could answer these questions. let's see how we did. So it's the little things you need to watch out for, okay? Uh, scale use, so you should know, right? Scale, I'm thinking, in this case, it's probably best to use diagram and actual, right? Because it's obviously making a picture of something. So I'm taking the diagram, which is 3.5 centimeters, and you put the actual there. Now, can you go ahead and just divide this and simplify? No, because the units are different, right? So you got to be careful here. Uh, so what you can do is turn this into millimeter, perhaps. Just multiply it by 10, right? 1 centimeter has 10 millimeters. Like that, then you can cancel out. Now you can go ahead and do the, some of you probably learned divide both sides by 0.25 maybe. Let me use this. So let's see if that works. I'm not even sure if this is gonna work. It should work. So it's just 140. What happened there? That means it's 140 over 1. Yes. So it's 140 to 1. So I would always expect you to clean it up a little bit for it to look decent, right? Like I wouldn't want this there unless there's a 1 on one side. Okay? So that's your scale. Scale factor. It's K is going to be 140 over 1, or just 140, or you multiply it by 100, right? 14 followed by 2 zeros percent. Right? Did anybody convert this to centimeters? It could be done, right? And then cancel out, and then you still get the same. You should get the same. Let me just you get 7 over 5 if you do that. No, sorry, never mind. No, you get 140. Never mind. You should get the same. It wouldn't make sense if it changes, right? Okay, so for C, this would, just by look at K, enlargement, right? Enlargement, comma, since K is greater than 1. That's all you need to do there. And it has been enlarged by a factor of 140. Okay? It's 140 times bigger than the actual. Okay? Okay. Question 2. The actual length of a pool is 20 feet, and its width is 15 feet. A scale model of the pool has a length of 30 inches. A, state the scale. It has to be reduced. B, state the scale factor. C, how much smaller / larger is the model and I'm going to throw in a D here as well. If the pool floor needs to be painted, and 1 can covers 115 square feet. And costs. I know this, sorry, English majors, you're going to be like, there shouldn't be too many ands, right? 1 can covers 115 square feet and costs $75, right? Calculate the cost of paint. This takes you back to the good old days, right, of IAPR. I will walk you through it so you don't need to be too worried about it. Let you write it down first. How about this? I'll let you try A and B, right? But I will show you how I always try to get rid of the units if possible. So for A, I must have forgotten how to use a pencil because I break these things like there's no tomorrow. Scale, so you got to be careful, corresponding sides, right? So they give you length and width of the actual, but they only give you the length of the model. So you want to kind of line them up, right? Length is 20, length is 30, right? So we're going to, for scale, in this case, we're going to use new and original. It's okay if you use new and actual. I'm okay with that. I like to be consistent so you're not mixing it up and then confusing yourself. But I'm going to use this terminology. Or did you use diagram? You probably used diagram actual. Yeah. I'm trying to think here how a student would think. All right, sorry about that. because you model, right? Diagram, yeah, okay, good. Let's do it that way. Diagram actual, and so I'm gonna grab the length. So the diagram has 30 inches, and the length is 20 feet. Units are different. I'm just gonna convert my 20 feet to inches quickly, and that is what, 240 inches. So 30 inches goes with 240 inches. Cancel, cancel. 30, sorry, whoever has the hiccups. 30 to 240. You can just leave it like that. I always cancel the zeros at the end, but let's go 30. You probably see already what it's going to reduce to, right? You can see it, like 3 times 8, right? But anyways, I don't see it. I'm just pretending to not see it. So it's 1 over 8. That's the scale, and therefore scale factor is going to be very easy. It's just 1 over 8. Let's state it as a decimal as well, and as a percentage. Okay. I used all decimals because it's a finite decimal. That's actually preferred. See how much smaller is the model. Model is, how would you answer this? How much smaller is the model? How many times? 8 times smaller. Or the original has been reduced by a factor of 8. Right? So there it is. Okay. Let's do D, which is probably, you need to review that one, right? Let me tell you this, whenever you're doing a renovation type question, listen carefully, okay? You always have to figure out how many boxes or cans or anything like that you need to buy first before you calculate the cost, okay? You cannot buy partial units, right? You cannot buy partial cans or boxes or whatever. So this is how I'm gonna do that. And because I wanna see the question, I just made that up as I give you notes. I'm like that. I go off script quite often. So D, determine number of cans first. Okay. So what I'm going to do is the area of the floor is going to be 20 feet times 12 feet. 15, sorry. 20 times 15. My bad. Right? And so that's 300. Area of the floor is 300 square feet because you're multiplying feet times feet, right? So it's square feet. So now you're gonna look at the fact that one can covers 115 square feet, right? I'm looking up on the question. So if one can covers 115 square feet, then I need X number of cans to cover 300 square feet. This is where proportional reasoning is probably the way to go. Okay, so you cross multiply. 300 times 1 is just 300, and 115 times x, divide both sides by 115, and it's 300 divided by 115, that's 2.608 cans, right? So what we need 3 cans. right? You cannot buy partial, no partial quantities. So now I'm going to go ahead and find the cost is 3 cans times, watch this, it's $75, right? For 1 can, so you can technically cancel out cans. I don't need you to do that when you're doing the cost, but I want you to see that the unit canceling is always there, right? The unit's canceling out. So it's 3 times 75, which is 225. Maybe later on I will introduce taxes. For now, I just want you to be able to do that. So this type of question on that worksheet that I created and I gave you, I believe there was one like this on the back side. So you can give that a try. Okay. Okay, so for homework, I'm going to do some textbook 479. I'm not going to assign all of them because 1, 4, 8, 9, I think 6. Sorry, I forgot 6, so that's the one I wanted. If you want to review, a little bit of the conversions, just look at that worksheet that I made, right? If you want some review that for tomorrow. But if you look at my notes and you work through these questions in the textbook, you should be in pretty good shape for tomorrow.